13.3, you are learning two symbols on 13.3. The first symbol is your sigma. And your sigma is like this. You already have it right there, but that's your sigma. What's going to happen is it's going to give you a number, like down here, that you have to plug into a given variable. So if it says like x squared, and you plug in all of the numbers and you add them up to where we have. This is called a sigma. It also, you can think of it being a sum, so you add it up. The next thing you're learning today is an exclamation. In math, you can use the electric. In math, the exclamation point is called a factorial. So if I say 3 factorial, that equals 3 times 2 times 1. What is 3 times 2? 6 times 1 is 6. So 3 factorial is 6. So what would 4 factorial be? It would be 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24. I want you guys to try 7 factorial right now and give me a number. What? Factorials are only whole numbers. Factorials are only whole numbers. Factorials are only used with whole numbers. Alright, so first of all, Eisenhower's, so first of all, 7 factorial is 7 times 6 times 4 times 3 times 2 times 1. And what did you guys get? 50/40. Very good. Alright, just a second. Before you jump to just see, I don't want to know, can your calculator do it? I want to know if you guys can do it. So just hold on a second. On this, we have 21 factorial over 20 factorial. You have 21 factorial, which means 21 times 20 times 19 times 18 times ... On the bottom, we have 20 times 19 times 18 times ... What happens is 20 cancels out with 20, 19 cancels out with 19, 18, and then so forth. So all these numbers cancel out. So our answer is 21. So what happens is, yes, I know a lot of you have already found your button on your calculator. You do have that button. But where do I have it? Oh, you have it. What? My question is, where's my bag? So, go to, first of all, go 7, go math, and you have to go over to the PRB. I backspace to get to the PRB, and it's number 4. So it gives you 50/40. But if you do 21 over 20, it can handle that. 21 math probability, so that's 4 divided by 20 math probability 4. It gives you 21. However, if you had a problem, like say I gave you a problem, which I will, 1,000 over 999, 1,000 factorial over 999 factorial, what does that equal? 1,000. However, your calculator cannot do this. Your calculator will say, can't do it. It'll say math, fraction, 1, so 4, divided by 999. It says overflow is right. Because it cannot think. It only knows to go 10,000 or 1,000 times 999 times 998. It cannot think. So the biggest thing that you have to make sure you realize is that you have 1,000 times 999, and this is also factorial, 999 factorial. So that cancels out. So you always have to make sure, because this could have been an 8, it could have been a 7, and you might have to do some calculations yourself. So you have to make sure you understand what the factorial means, that it's every number straight down.
So say it was like 1001, like would you do 1001 times 1,000?
So 1001 over 99?
Yeah, 99.
So it would be 1001 times 1000 times your 999 factorial, and 999 factorials would cancel out, and it would be that.
Okay.
Yep, and then whatever that would be, so you would go, oops, quit, 1001 times your 1000, and gives you 10010000. Yep. Yep. All right. So these are the formulas that we have. We still have arithmetic and geometric, and the only difference is in this section is that it's just saying to find the sum, just like we've been doing, to find the sum. You must always determine if it's arithmetic or geometric first to be able to use these two, like if you want a shortcut about adding them up. All right, it says here, example 2. 6 times 3k, and k is going from -2 to 2. So first of all, what? -1 to 2. So what is my numbers from -1 to 2? We have -1, 0, 1, and 2, because it's all of those numbers. So you are plugging in for k, so you have 6 times 3 to the -1. And then we're going to keep changing this to get our sequence. So in your calculators, I want you to clear it out. Go 6 times 3 raised to the -1. Okay. Yep. Recall what we just wrote. So second entry. Delete your -1 and put a 0. Gives you 6. Recall, how do I recall? Second entry. I'm going to change my 0 to a 1. 18. Second entry, change my 1 to a 2. So I have 54. It says to write the sum of the series. That's my series. Now it says evaluate. What does the word evaluate mean? Solve it. Add it up. So I'm going to go 2 plus 6 plus 18 plus 54. Since there's so little numbers, I would say that that would be the quickest way rather than using our formulas from yesterday. You definitely could use the formulas from yesterday, but since it's so short, I would just add it up. If you wanted to use the formulas, what formula would you use? Is this arithmetic or geometric? 2, 6, 18, 54. Geometric. So you would use your geometric to do this. So if you wanted to do it, just so you know, it'd be your first term times your 1 minus your difference, which is how much each time? Goes up by, what are we multiplying by? 3. N, what did N mean yesterday? A sub n is last term. What does N mean? How many terms? 1, 2, 3, 4, so it's to the 4th, over 1 minus R. R was a ratio of 3. If you throw that into your calculator, you'll also get 80. So 2 parentheses 1 minus 3 raised to the 4 divided by your -2 gives you 80. It must be geometric to be able to use that though. So if it's not geometric, you can't use it. So if you're not for sure, just add them up. If you're not for sure it's not geometric, make sure you just add them up because evaluate means add. Tonight's homework does not have all geometric and arithmetic, so you can always add them up when you evaluate. All right, it says evaluate it. So first of all, what numbers are you going to be putting in for your H? 7. It is
7, 8, 9, 10, 11.
7, 8, 9, because you remember it's going 7 all the way to 13. So 7, 8, 9, 10, 11, 12, and 13. You are plugging in for H. So literally, I'll get you started, and then I'm going to have you do it to see if you get the right numbers. You're literally going 3 times your 7 plus 2 gives you 23. And you can second recall it and change that 7 to an 8. 26. So I want you to fill out those numbers. And evaluate it. Whichever way you want to do it, by either evaluate it by adding them up or using your formula. So we have 23, 26, 29, 32, 35, 38, 41. Is this arithmetic or geometric? Arithmetic. Because it's arithmetic and there's a lot of numbers, I personally wouldn't want to add all those up, so I do my n over 2 number of terms. 1, 2, 3, 4, 5, 6, 7. There's 7 terms divided by 2 times your first plus your last number. And hopefully you all got 224. If you add up all these numbers, you should get that. Questions? If I were to take something, anything, and I took a third of it, and then I took a third of it, and I take a third of it, and I take a third of it, will I ever get to 0? No. What that is it's called infinite. So your infinite series will go on forever. However, you can get a sum for your infinite series. To get a sum for your infinite series, you have S is equal to G, and where G is your first term, so if you want to, you can call that G1, divided by 1 minus R is your ratio. So we have here your first term, and R is always your second term divided by your first term. Because that's how, if you ever don't know what term it is. So we have 7, then 7 thirds, and then 7 ninths, and so forth. Does everyone know what G1 is? What is G1? First term, which is 7. And then we have 1 minus R. What are they multiplying by? A third. If you go and you say 7 thirds divided by 7 in your calculator, you will also get a third. So if you ever need to, you can always do that. So I want you to make sure you know that you have to put parentheses around that. Put that in your calculator. Make sure that you get your 1050. Or fraction it and you get 21 over 2. 10.5, yep, or 21 seconds.
What is that showing?
This is the sum of all of these. Even that it goes on forever, you still can get approximately what it is.
Oh, it's okay.
Yeah, pretty much. I mean, it's because you remember how, because yeah, well, if it goes on forever, it's still, you're getting close to 0, so you're getting close to adding 0, but you're not really adding 0. So you can, that's how you get the, what it is. You can think of it more of approximation, but it's more what it is. That's what it, how it can be. Now, if you, in your calculators, do you know how when you have this, you have a repeating, actually we're going to change this because this is your homework number. I'm not going to do your homework number. So put 3.678678. If you had the number 3.678678, you all know that that can be written as a fraction. You've all learned that that can be written as a fraction because it's a repeating decimal. And what that is that's an infinite, it's an infinite geometric series, and that's why it can be written as a fraction. So we're going to take what we learned today and write it as a series and then write it as a fraction. So the first thing is, can you tell me from this number what is the thing that's repeating? 678 is right. 678 is my repeating. So the first thing we're going to do is we write what's not repeating. So that's the 3. And then we add what's repeating. So we go 0.678. So in my calculator, to show you what I'm doing, I went 3 plus 0.678, which gives me 3.678. So hopefully you agree with that. But now I want 678 to be behind it. So I want to add this part. So what can I add to it to get that next part? Yeah, so 0.000678. And because it's repeating, it goes on forever. What could my next one be? How many zeros would I have? 6 zeros. 1, 2, 3, 4, 5, 6, 6, 7, 8. And then we're going to say that it goes on forever. Remember, your calculator is programmed to do stuff. This is what when someone programmed your calculator, this is what they programmed your calculator to do, to create a fraction. So what we are doing now is how your calculator is making a fraction. And I'll tell you that I didn't have this, so I had to make a fraction without it. So this is stuff that people used to have to do all the time, but now luckily you guys have a calculator that's smarter and that can do things like this. However, we have here, it says find a fraction. Do you agree that this is the finite geometric series? Do you agree that this is going to go on forever and it is a geometric series? All right. So what this says is that we can use this to be a ratio to find what this is what it's kind of being added up to be, what it's being the ratio. So what you have to do is we're going to keep this 3 because that's the whole number. We have to keep the 3 to keep the value. Plus, it says G1. That's my first number. So what's my first number of the series is 0.678.
Why is it 3?
Because it still has to equal this. And the 3 is the not repeating. So this is only for the repeating series. This only goes for the repeating series. So it's 3 plus whatever we're doing. I'll prove it to you. But we have here, so then we go 1 minus our R. So how do I find R? What did I have to multiply 0.678 by to get 0.000678? How can I find out what R is? Second term divided by first term. So second term of your repeating thing, so 0.000678 over your first term, 0.678. What is this relationship to? What can you use this for? The infinite geometric series. Is 3 repeating? The only thing 3 has to do with this is that it's the whole number. So that's why we brought the 3 down, because this only can go for the repeating part. So, you guys put that in your calculator? What did you get? 0.001. Yeah. What is 1 minus 0.001? 0.999. Do you guys know how you can get rid of a decimal? I need to get rid of these decimals. Need to move them over 3 spots. So I have 3 plus 678 over 999. Hopefully you guys are seeing the fraction.
How can you just do that though? Like,
Because it's multiplying by 1,000 on top and bottom. And if you do whatever you do to the top, you do to the bottom, it's the same number. So, this reduces. Does anybody know what it can be reduced by? 3. 678 divided by 3 gives me 226. 999 divided by 3 is 333. How can I add 3 plus my fraction? What do I have to do? Yep, so I have to multiply 3 by 333, which gives me, I'm going to do that over here, 999 over 333, because this is still 3, plus 226 over 333. Last, I just add across. You get 1225 over 333.
can't you just add 333 or multiply 333 by 3 and just add 226 and put it on it? Instead of,
Yeah,
oh,
it's the same thing. Mm-hmm.
Why would we multiply 3 on the bottom?
What do you mean, where? This? How do you write this as a fraction? 3 over 1, right? But I need it to be a common denominator of 333. So what do I have to multiply that 1 by to get 333? 333, right? So I multiplied 1 by 333, and it gave me 333. And then I multiplied 333 by 3 to give me 999. And then I added across to give me this. Yes. Yep. All right. Those of you that have this calculator, I'm going to show you something. If you go in your calculator, when you go 3.678, math fraction, it doesn't work, does it? Because your calculator only knows as much as it's programmed to know. It doesn't know that it's repeating. It doesn't have enough information. However, if I go 3.678, what is my next 3 numbers? 678, my next one, and my next one. Math fraction, it will give me the answer. However, you have to give it more information than what you were given, so you do have to do it out when you do it. Also, just so you guys see that this should be the same as what we started with. If we divide that out, it should give us what we started with. 1225 divided by 333 gives us 3.678678. But the 9 is because the calculator rounds. Remember, the calculator rounds because it's not smart enough not to.
Why do we have to do the whole thing when you just put them in the arithmetic?
Say it again. First of all, are you asking me why I didn't just show you math fraction?
No, like you can plug in that top equation and then get the answer
from here for two reasons why I did all of it out. One, for you to make sure you know how to do it, because there's going to be times in life that you need to explain it. Second of all, there's a lot of kids that don't have the capability of the math fraction, but you should know how to. This is all just figuring it out. It's all solving it out. But now that I showed you, we've done it once. However you do it next will be fine. But you do need to be able to at least know how to solve things out. All right. With that said and done, questions about that?